okay, the key to these guys is to remember the mechanical energy equation, which is mechanical energy is equal to kinetic energy plus potential energy. So if you increase the kinetic and don't change the potential, you're going to increase the mechanical. If you can increase the potential and you don't change the kinetic, you're going to increase mechanical. One key question you kind of want to ask yourself is, was energy added to the system? So if energy was added to the system, the mechanical energy is going to increase in these situations. If energy is taken away, the mechanical energy is going to decrease. If there's a situation where the kinetic and the potential are changing, where kinetic is decreasing while the potential increases by the same amount, the mechanical energy is going to stay the same. So if you're looking at your homework problems, let's look at a few where we might see mechanical energy increase. One of those is the Hulk question. Okay, so Hulk is going to be punching Thor. And Thor is originally standing here. Okay, Chris Helmsworth. Beautiful, beautiful Chris Helmsworth hat, cape, muscles. Okay. This is not my best Chris Helmsworth picture. Oh gosh, the muscles have gone wrong. Okay, anyway, here he is. Dun, da, da, da. Okay, originally he's just standing there and he's not moving. Okay, so his kinetic energy is equal to 0. And they didn't say anything about him going up or down, so we could say, okay, his potential energy is 0. Afterward, he's going to be bombing along, also sad. So his kinetic, he's now going to have kinetic energy, and, you know, maybe he's flying through the air. If he does, he's got some potential. Either way, originally he didn't really have any mechanical energy. Now he's got a bunch. So in this situation, the mechanical energy increased. In the situation with Ed Sheeran, here's Ed Sheeran, okay. Okay, he originally was moving on a flat dance floor, and it says he's going to slide to a stop. So he had kinetic energy. He didn't have potential energy because it's a nice flat floor. By the time he stops doing his little dance, his kinetic energy will now be 0. His potential energy will be 0. His hair will still be fabulous. So he will have lost mechanical energy. So we would see mechanical energy had decreased between those two. When we look at the one where we're talking about somebody going back and forth in a skate park, what's really important here to pay attention to is they went out of their way to say, okay, if you're going back and forth, they're saying, okay, look out for there's no friction and there's no air resistance. Those two are big hints because it means that whoever wrote the question is really taking their time to make sure that there's no outside forces affecting the situation. So in this setup, the skater's going to start out with potential energy up here because they're off the ground. By the time they get to the bottom, they will have no potential energy. But where has that gone? Well, it hasn't gone into friction, hasn't gone into air resistance. So that has turned into kinetic energy. So he now has kinetic energy. Once he goes back up the ramp over here, that kinetic energy will have turned back into potential energy. So this energy is going to kind of slosh back and forth between potential and kinetic. But overall, the total amount is going to stay the same. Why? Because there was nowhere for it to go. It couldn't get lost. So these words are big hints that mechanical energy is probably going to be conserved.